Hello, welcome back students for the new video based on reduction formula. Basically, a reduction formula is an recurrence relation which reduces the integral of a degree n in terms of n minus 1, n minus 2 and so on, which reduces the higher degree in terms of lower degree. The successive application of a recurrence relation finally end up with a function of degree 0 or degree 1, so that we can easily complete the integration process. Fine. Now let us discuss the reduction. What is the reduction formula for sin raised to n x in terms of n minus 1, n minus 2. So to achieve this, we will start with in. In is equal to integral runs from, or we are taking indefinite, which is sin raised to nx into dx. Whenever there is a n here, this is power is n, that stands for sin raised to n, that is in. So to integrate this, I am going to write this as this is sin raised to n minus 1x into sin x into dx. To find the integration, I want to apply integration by parts. So for that, I need a product of two terms. First function is u and second term is v, and I am applying integration by parts. Integration of product of two function uv is equal to first function integration of second function minus integration of second function into differentiation of first function. Okay, so this is the integration by parts. Now I will take sin raised to n minus 1x as a first function and sin x as a second function, and applying integration by parts. First function sin raised to n minus 1x, integration of sin x is minus cos x minus integration of sin x is, you can write directly, minus cos x, and differentiation of sin raised to n minus 1x is n minus 1 into sin raised to n minus 2x into dx, into not dx. Again we have to apply chain rule here. Okay, again integrate, that is differentiation of sin x is, which is cos x into dx. So I am applying x raised to n formula. X raised to n is n x raised to n minus 1. Again x is sin x here, differentiation of sin x is cos x. Fine. Now which is equal to minus sin raised to n minus 1x into cos x. This is minus minus plus. Take this n minus 1 outside. So what is remaining? First we can write sin term, sin raised to n minus 1x into cos x into cos x is cos square x into dx. So further I will keep first term as it is, sin raised to n minus 1 into x into cos x as it is, plus n minus 1 into integration of this term is as it is n minus, this is 2, n minus 2 into x. Cos square can be written as 1 minus sin square x by using the first identity, cos square x plus sin square x equal to 1, then cos square x equal to 1 minus sin square x, which is equal to minus sin raised to n minus 1x into cos x plus n minus 1 into, I am multiplying this sin raised to n minus 2x into 1 is integration of sin raised to n minus 2x into dx first term minus this n minus 1 into integration of sin raised to n minus 2 into sin square x. When bases are same, powers are added, that is n minus 2 plus 2. So that is, you will get only sin raised to nx into dx. I am multiplying this total integral into 1, this total integral into sin square x, you will get this term. As you know that we have started with in, okay, you keep it first term as it is, sin raised to n minus 1 into x into cos x plus n minus 1 into, look at, when there is a in, it is integral of sin raised to nx. We'll go in the reverse order. When integration of sin nx is in, so instead of n, if I replace n by n minus 2, then it will become in minus 2. So here also similar fashion, I am writing this is in minus 2. Okay, so next minus, okay, this is n minus 1 times of, this is in. Hope it's clear, right? Fine. Now what I am doing is, I need to have only one in. Since there are two in, I will transform this minus sign into left side. So what will happen? Okay, just you can write in plus n minus 1 times of in. The right side minus sin raised to n minus 1x into cos x plus n minus 1 into in minus 2 as it is. I will take in common here. It is 1 plus n minus 1 remaining. The right side as it is, sin raised to n minus 1x into cos x plus n minus 1 times of in minus 2. So plus n minus 1 get cancelled and you cross multiply n. Therefore, what is in? In is sin raised to n minus 1 into x into cos x divided by n plus n minus 1 divided by n into in minus 2. I have cross multiplied this n to right side. Okay. Now look at. So this is called in. What is in? You people already aware. This is integration of sin raised to nx into dx. So therefore, integration of sin raised to nx dx. Look at, this is n. We have expressed in terms of n minus 1, n minus 1, in minus 1, and in minus 2. So this is the reduction formula. This is the reduction formula for sin raised to nx into dx. Okay. Now let's find out. What is the integration runs from 0 to pi by 2 into sin raised to nx into dx. So I have already have integration of sin raised to nx value, just you can write here. This is integration of minus integration of sin raised to nx. This is n minus 1 times of x into cos x divided by n plus n minus 1 divided by n into in minus 2 between the limits 0 to pi by 2. Okay. So what I am doing is, I am going to substitute upper limit. What is sin pi by 2? Sin pi by 2 is 1, and what is cos pi by 2? Cos pi by 2 is 0. Cos pi by 2 is 0. So therefore the upper limit becomes 0, and substitute this lower limit. Sin 0 is 0. So by substitution of upper limit and lower limit, the first term vanishes. It will become 0. Okay. So since it containing in terms of n, so we have to keep this as it is. N minus 1 divided by n times of n minus 2. Therefore, as usual, you people know that this is in, therefore in can be written as n minus 1 divided by n times of in minus 2. Okay, look at, we have expressed n in terms of n minus 2. As I told you already, what is the reduction formula? Reduction formula to express the higher degree terms in terms of lower degree term. So now we are going to calculate what is in minus 2. Just replace n by n minus 2 in this formula. N is n minus 2. N become n minus 2 minus 1 is n minus 3 divided by n minus 2. This is n minus 2 minus 2 is n minus 4. Okay. Similarly, you can find out what is n minus 4, in minus 4. This is n minus 5 divided by n minus 4 into in minus 6. Substitute here or here, doesn't matter. Okay, fine. Now, let us substitute backwardly in this formula. Therefore, in is equal to, keep it this as it is, n minus 1 divided by n into in minus 2. In minus 2 is this, n minus 3 divided by n minus 2. What is in minus 4? n minus 5 divided by n minus 4. Okay. It is end with either even number, even or odd. That is, it is end with I2, I0 means even, or end with I3, I1. Okay, look at, if it is end with last term, is if I take it as a even number, okay, or odd number, let us take first, which is equal to n minus 1 by n minus 3 by n minus 2, n minus 5 by n minus 4, so on. Okay, it end with I3. I3 is odd. Similarly, if n is odd, okay. Similarly, n minus 1 by n minus 3 by n minus 2, n minus 5 by n minus 4, so on, it end with even if n is even. Okay. Now, look at carefully, which is, so let us calculate what is I3. What is I3? Substitute n is equal to 3 in this equation. So it will become I3 is equal to 3 minus 1, 2 divided by 3 into I1. Okay, fine. Next, similarly, substitute n is equal to 2 here, you will get I2. I2 is 1 by 2 times of I0. As we know that, what is in? In means 0 to pi by 2 sin raised to nx into dx. Substitute n is equal to 0. Okay, you will write next term, just look at. First two terms, first these are as it is, n minus 1 by n minus 3 by n minus 2, n minus 5 by n minus 4 as it is. Okay, so on, it end with I3. I3 means we can write 2 by 3 times of I1 if n is odd, n minus 1 by n into n minus 3 by n minus 2 into n minus 5 by n minus 4, so on, and with 1 by 2 times of I0 if n is even. Okay, now let us find out I0 and I1 in this formula, substitute n is equal to 1. So I1 is equal to, take n is equal to 1, it will become integration of sin raised to 1x between 0 to pi by 2 into dx. Integration of sin x is minus cos x between 0 to pi by 2. Okay, substitute upper limit, which is cos pi by 2 minus cos 0. Cos pi by 2 is 0, cos 0 is 1, minus 1 plus 1. So similarly you can find out I0, 0 to pi by 2. Sin raised to 0, sin raised to 0 is just to 1 dx. Integration of 1 is x between 0 to pi by 2. Substitute upper limit minus lower limit. The answer is pi by 2. So finally you can write it as, look at, integral runs from 0 to pi by 2, sin raised to nx dx value is, okay, this is n minus 1 by n into n minus 3 divided by n minus 2, n minus 5 by n minus 4. So on 2 by 3, what is I1 value? I1 is, this is 1. If n is odd, n minus 1 by n minus 3 by n minus 2 into n minus 5 by n minus 4, so on, which is 1 by 2 into pi by 2, because I0 is pi by 2, if n is even. Okay, so this is the nth derivative of sin raised to nx. Also integration runs from sin raised to nx between the limits 0 to pi by 2. Okay, for example, let us find out what is the integration runs from 0 to pi by 2 sin raised to some 4x. Okay, what is the answer? 4 is the even number, right? You can substitute here. N minus 1, n minus 1, n minus 1, n is 4, 4 minus 1 is 3 divided by n is 4. Okay, fine, 3 by 4. Substitute n value is 4, 4 minus 3 is 1 divided by 4 minus 2 is 2, and last value we have to take it as a pi by 2. Okay, this is pi by 2. The answer is 3 pi by 16. 3 pi by 16. Okay, fine. Similarly, you can calculate sin raised to any power. Thank you so much for watching. Please subscribe our channel CGATMaths, and please share to the maximum students which are very necessary about these concepts. Thank you once again. We will meet in the next video. Thank you so much.